It is finally Friday. Yay! Friday, February 5th. Let's check our bell work. So for the first set here, it says write each mixed number as an improper fraction. So let's do that. I can do that by saying 4 times 6 is 24, and 24 plus 3, 27 fourths. For number 2, if I have 11 and 1/9, that means I have 9/9 11 times, plus this extra 1. So 9 times 11 is 99, plus 1 is 100. And my denominator never changes. 109ths is what you should have. For number 3, this means I would have 9/9 7 times, plus that extra 4. And 9 times 7 is 63. 63 plus 4, 63, 64, 65, 66, 67 ninths. So first 3, done. Now I ask you to do the opposite of that. I ask you to write each improper fraction as a mixed number. So you can do this by asking yourself, how many 5/5 are there in 24? That's your whole number. And then the leftovers are your little leftover fraction. I'd like to get my whole number by asking myself, 5 times what gets me closest to my numerator? So 5 times 4 is 20. 5 times 5 is 25. That's too high. So I know my whole number is 4. And 5 times 4 is 20. To get from 20 to 24, there's 4 left over. Denominator never changes. For this, I can fit one full group of 7 sevenths in 12. So that's the whole amount. And to get from 7 to 12, it's 5. Denominator never changes. For number 6, I know that 10 times 9 is 90, and that's as close as I'm going to get. And to get from 90 to 99, I have 9 left over. Denominator never changes. And remember, you can always check your work by doing what you did here. 10 times 9 is 90, plus 9 is 99 tenths. 7 times 1 plus 5 is 12 sevenths. 5 times 4 is 20, plus 4 is 24 fifths. Okay, now we're going to simplify again. The largest number that goes into 20 and 50 is 10, so I'm going to divide them both by 10, and I get 2 fifths. For number 8, 5 is the largest number that divides into both. 5 divided by 5 is 1. 25 divided by 5 is 5. So 5 25ths in simplest form would be 1/5. For number 9, maybe you looked at this and said, well, they're both even, so I know 2 will go into both. But if you did 2, you'd get 4/10, and then 4/10 can both be divided by 2. So let's just divide by 4, and if you divide it by 2 and then divide it by 2 again, you'll get the same answer. 8 divided by 4 is 2, and 20 divided by 4 is 5. So you shouldn't have 4/10, you should have 2 fifths. Okay, now I ask you to calculate each product. Again, that's a result of a multiplication problem. And I told you to simplify when you can. As long as all went according to plan this week, you have learned how to cross simplify using the commutative property. You just learned how to do it yesterday. So if you didn't use that strategy for doing 10 to 15, that's okay because you simplified your answers and you should get the same thing. But I'm going to go ahead and use that process because we'll get the same answer and it's a good review of the process. Okay, so for 2/9 times 3/5, we saw yesterday that in the commutative property, this would mean 2 times 3 over 9 times 5, right? Well, we're allowed to change the order of numbers that we multiply. So I could look at this as 2 times 3 over 5 times 9. You don't have to write this part. And 2/5 times 3/9. This 3/9 can be simplified, right? If I were to simplify 3/9, wouldn't I divide them both by 3? And 3 divided by 3 is 1, and 9 divided by 3 is 3. So 3/9 can be written as 1/3. So instead of doing all of this and like rewriting it all out, we saw that we can just cross simplify instead of moving the 9 over here. It works the same. So if I see that numbers that are diagonal from one another have a common factor, then I'm going to go ahead and cross simplify before solving the problem because then I won't have to simplify it at the end. So we already said for 3 and 9, 3 goes into 3 once and 3 goes into 9 3 times. Now when I multiply, I can say 2 times 1 is 2 and 3 times 5 is 15. So 2/15 should be your final answer. If you did this the other way, then 2 times 3 is 6 and 9 times 5 is 45. You'd have 6/45, but those are both divisible by 3. So now you'll have to divide them both by 3. And 6 divided by 3 is 2, and 45 divided by 3 is 15. And you'd still get the same answer. It's just that as these digits get larger, it's harder to see the largest factor that divides into both. So this can save you some grief at the end by learning how to do this, especially for a problem like number 11. So right here, I see a 3 and across from it another 3. Well, 3 goes into 3 and 3 one time. So I'm going to change this to a 1 because 3 divided by 3 is 1 and 3 divided by 3 is 1. And now I'm left with 1 times 1 is 1 and 4 times 1 is 4. So you should have 1/4. Originally, you would have 3 over 12, but 3 goes into both of those. 3 goes into 3 once, 3 goes into 12 4 times. 1/4 is the final answer I want you to have. I want it to be in simplest form. For number 12, when I look diagonal, 4 and 9, nothing can be done. But 5 and 15 have a common factor of 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. So I can now multiply across the top. 1 times 4 is 4. 9 times 3 is 27, and 4 27ths is it. So instead of having to figure out what 9 times 15 is, like, we know 5 times 4 is 20, but 9 times 15, we'd have to do some work, right? If you cross simplify beforehand, we end up at the simplified answer. Okay, let's keep it going. So I'm multiplying by a whole number, and remember when we have a whole number, it just makes it a little bit easier when we're trying to use the standard algorithm to give it a denominator, put a 1 under it, and now I can still use this cross simplifying. The 2 and the 1, there's not really anything I can do, but 9 and 36 I can. I know that 9 times 4 is 36. That means that 36 divided by 9 is 4, and 9 divided by 9 is 1. So 2 times 4 is 8. 1 times 1 is 1. And if we're going to write this in simplest form, this is improper, right? What's 8 divided by 1? It's 8. So instead of saying 8 over 1, give me 8 as your final answer. Okay, I don't know why I have this equal sign so far over here, but whatever, it's all right. Let's put a 1 underneath that 32. We didn't change the value, we're just making it so it's easier to use that standard setup. 5 and 1, there's not much I can do, but with 8 and 32, I know that 8 is the highest number that goes into 8 and 32. 8 divided by 8 is 1, and 32 divided by 8 is 4. Now I'm going to multiply across the top. 5 times 4 is 20, and 1 times 1 is 1. And 20 over 1 is equivalent to plain old 20. So 20 is what you should have for 14. And finally, number 15, I'm going to put that 1 underneath the 12. And before I multiply, I notice that 12 and 6 have a common factor. The largest common factor would be 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So now when I multiply across the top, 2 times 5 is 10. 1 times 1 is 1. And 10 over 1 is equal to 10. All right, you're all set.